Good afternoon. I hope you've enjoyed the sessions this morning. For those that don't know me, my name's Paul Hann. I'm one of Esri UK's solution architects, and I generally work on some of our customers' larger software development projects. So one of the most common uses of our APIs is not necessarily building apps from scratch, but rather using our APIs to enhance existing applications, to add spatial intelligence and capabilities to your applications. And that's kind of what I would like to talk about today. The examples I'm going to use are relatively simple but powerful examples. But the reality is our APIs and our SDKs can do a lot more than what I'll show you today. So I'll only really give you a flavor for what's possible. As we'll be kind of looking at some code in this session, you all know that when you look at code on a projector and trying to read it while someone's presenting, it's very hard. I've put all the code for this session, for the demos that I'm doing today, it's all been put onto GitHub at that address there. I'm also hoping, I may actually stray from my original plan. I think it'd be quite nice to actually have a bit of a Q&A session at some point during the session, so I'm hoping to have time for us to discuss the sorts of integrations that you might want to be doing in your applications. So, in order to be able to demonstrate something to you, I needed a base application. So what I've done is I've actually thrown together a very simple bootstrap form application using an online sample. Now, what I'm doing here could be done in your own web applications, but equally you could use the same techniques and approaches to extend extensible application platforms like Dynamics or Lagan or SharePoint or Joomla or Drupal. You're able to use these same techniques to extend your own existing applications. The example I've chosen today is an example from a local authority that I once worked with. They were able to save around about £50,000 a year and deliver a much greater quality of service by making just a few simple changes, by adding a few simple aspects of geographical intelligence to their existing forms application. So some of you may be aware of the controversy around houses of multiple occupancy. Who here's heard of HMOs before? Yep, a fair number. So the controversy is that there's a feeling that parts of cities are being turned into student ghettos, and that families are being driven out of these areas. So local authorities who have the responsibility for licensing these HMOs generally try and combat this by putting in place policies around the percentage or the proportion of each area that can actually be licensed as HMOs. Whilst this can prevent the creation of student ghettos, it can also be quite a time-consuming process to evaluate. The local authority I worked with, every time they received an application for HMO, one of their officers would get out this big map, and on there they'd plotted and put a little marker where every single licensed HMO was. So every time they got an application, she would sit down, she'd get a piece of paper out, and she'd sit there and say, well, the new HMO application is here, so let me go and count. And she'd sit there and count the number of existing HMOs and write down some statistics on a paper, and then take that to the licensing committee and use it to advise whether the HMO should be approved or not. This officer pretty much worked full time doing this process. Equally, the landlords were getting increasingly frustrated because every time they wanted to apply for HMO or consider buying a property and applying for HMO, they would come in and say, well, I'd like a HMO here, but would I be approved? And the answer was, well, you pay your £50, we'll go away, and in 4 to 6 weeks, we'll tell you whether it's been approved or not. So there was a lot of frustration about the lack of transparency about this process and the amount of money that landlords were losing on HMOs which never really, ever were going to get approved. So that's the process, that's the application that I'm trying to improve through geographical intelligence. So let's have a look at the application that I put together just as an example of as a base for us to extend using the ArcGIS platform. Okay, just bear with me a sec, it's on the wrong screen. Okay, so I'm sure you'll have many sort of forms applications similar to this where someone might come in and they might type in address, and then they have some additional options such as the name of the landlord, number of bedrooms, the type of HMO, and obviously there would be information in that form about how you'd go about paying for your application. So this is the base application that I'm going to start with and extend. So we just look at what's behind that. Essentially, like I said, it's just been built from a Bootstrap starter template. It's just a basic forms application with all the normal sort of Bootstrap stuff that you'd expect. The only thing I've added to this is I have added our JavaScript API because it gives a really nice address search tool, and it just saved me building an address search tool. And you can see the code behind that simply just it uses our JavaScript API to embed a search widget, and we listen for the search widget, for the search complete event in the search widget, and when that search has been completed successfully, it will show the step 2, the second part of that form. So that's the base application that we'll work with. But again, I don't want you to get too hung up on this application. This is just an example for us to work with or demo with during this presentation. This application could be anything. Like I said, it could be your existing forms application builder. It could be any of the sort of application platforms that you might use. Anything that allows you to embed snippets of code into it, essentially. Oh, sorry, I've lost my slides. Okay, so let's kind of start at looking at how we might be able to improve that form. So at the moment, users can go in there, they can input an address and search for an address, but there's nothing stopping them from choosing an address outside of their council boundary. So wouldn't it be useful if we could restrict the addresses that they use without having to maintain a custom gazetteer that only had your addresses in it? Wouldn't it be useful to be able just to define a boundary of the addresses that you're interested in and restrict it, the address search by that boundary? So, for example, like this. So let's go and search for, oh, I'm not doing, okay. Let's try that again. Something like this. So let me just type in an address. Let's take one in Glasgow. And very simply, it's told me that because that address is not within my council boundary, that I need to go and apply elsewhere. So let's look at how that's achieved in the code. So essentially, here's again that base application. The first thing I'm doing here is, actually before I dive into that code, let me just show you what we'll, let me just show you this. Okay, so what I'm going to use to achieve that capability, that functionality, is I'm going to take advantage of the REST API. So we have here a feature service that contains a layer which is the boundary of our notional council called Sunnysshire. I know it looks a bit like Edinburgh, but no, it's Sunnysshire. So you can see that we've got a feature layer that contains that information. And if we drill into the REST endpoint for that feature layer, we start to see the capabilities that are available to us as developers. First of all, if we scroll down to here, we can see that there are a number of different operations, including different types of queries, different sort of create, update, delete, edit functionality, and other things that we can use to manipulate our layer or interact with our layer. In this example, I'm just going to focus on the query operation. And again, you start to see the range of capabilities that are available to you. You can do a non-spatial query. So I can simply go in and say, I want to return everything, which is quite easy because there's only one record in this data set. And if I just run a GET request against that, you'll see I get the result, which is the boundary that I've selected. I can choose to pass in a geometry. So I could pass in an address point, which is what we're going to do in the code sample that we're going to look at shortly. We can define what sort of geometry I'm passing in. We define what sort of spatial relationship might exist between that geometry and the data that we're querying. We can even add things like buffers by putting a distance on that initial geometry that you're passing in. So this would be useful if you're saying, give me everything within 500 meters of this address. You could pass that in as a query to your data through the REST endpoint on that layer. I can control whether what field or data is passed back, so I could choose all fields, or I might just say give me the object ID. I can choose whether I want it to return the shape or not. Now this is useful because if you're not displaying this data in a geographic information and you're querying data that is complex in terms of its geography or geometry, it will be a lot more efficient and quick just to return the attributes rather than returning the attributes and the geometry. So you can choose whether you return that or not, or whether you just return a centroid representing that geometry. You can choose what levels of precision. There's a lot of things you can choose here. Essentially, you can choose just to return the IDs of what you're querying. You can order your results. You can define statistics. So rather than returning the results, you can tell the server to return the statistics about those results. And ultimately, you can choose what format you want that data to return in. So if I just run that one, you'll see we get a JSON object that not only does it return the list of features or the data that we're interested in, it also returns metadata about that, such as what fields are in the data that your applications can use to understand that result. So I think when you start looking at what that REST endpoint can do for you, it starts to get a bit exciting as a developer, because you can see how you can do many things without having to write a lot of code. So let's go back and look at how that's implemented in the code. So in order for us to make use of the REST API, I could essentially just write in any language that supports web requests. So this could be, I could write something in .NET, I could write something in Python, Go, any language, Perl, Pascal, because REST is, as Richard said earlier, it's not technology specific. In this case, what I'm going to do is I'm going to use our JavaScript API, because our JavaScript API wraps up all of that logic into how you communicate with REST into some very simple functions, essentially. So what you'll be able to see here is I have taken that original code and I have added in two of our modules from the JavaScript API. The feature layer module that allows us to talk to feature layers and wraps up a lot of the functionality around that conversation. And the query that allows us to instantiate a query and structure all the variables that we're going to pass to that feature layer. And then what I've done is I've hooked back into that onSearchComplete function or event. And the first thing I do is I instantiate a feature layer object using the REST endpoint that we've just looked at. I then instantiate a new query object, and I pass to it the geometry of the address that the users just searched for, which essentially is a point geometry on the map. I then tell it to return me the object ID, and because we're not really interested in the shape that comes out, the geometry that comes out, I'm telling it not to bother returning me the geometry. And then what I do is I use that query to run a query against that boundary layer. And then I look at the results and say, if the length of results is greater than 0, that address must be within the boundaries. So I go on and again show that second section. If it is 0 or less than 0, then I need to tell the user that they're not within the right boundary. So hopefully you can see there that in a relatively few number of lines of code, I've been able to build that functionality. So if we just jump back to that example there and just run it again, those lines of code are allowing us to determine whether the address is within the council boundary or not, and tell the user that it's not in this case.
Can you filter down the search when you actually search that it only searches for objects that are within that boundary?
Yep, so in that example, I only passed the geometry as the query, but you could equally add a where clause, which would allow you to use any of your sort of standard SQL to filter down the results that are returned in that scenario. So what have I essentially done there? Just to summarize, I've basically hooked into the select address event to get the address coordinates. I then have used a spatial query to query the boundary layer, and if this returns a result, then the address is correct, otherwise it's not. But wouldn't it also be useful to present to your users not only the boundary of the council within your form, but also something to indicate the likelihood of their HMO being approved or not? Again, the ArcGIS platform makes this relatively simple to do. So let me just look at how you would do that. The first thing you would do is you can use ArcGIS Online or ArcGIS Enterprise to author that map. So you can see here I've got a map in ArcGIS Online where I've taken that boundary layer, which is here. I've symbolized it very simply, just with a dotted outline, and displayed it on a map. What I also have here is a layer, another layer that I've created that has a point for every single HMO within Sunnyshire. In theory, I could just go ahead and embed this map into my application. But the problem with this kind of map, where you just have points representing the locations of things, is there's often quite a nervousness about including exact locations of things in your maps. I know a lot of local authorities get a bit concerned about that, but equally, it doesn't tell you the whole story. So for example, we see a point here, and it would be easy to assume that that's just one HMO, but when we click on it, we find that there's actually two at that location. So it could, so the data doesn't really tell the full story. So what I have actually done here is I've used the analysis tools within ArcGIS Online to analyze patterns and create a hotspot map using a 500-meter boundary. And what this ultimately gives us is a layer that looks like this, which again allows you to see concentrations of HMOs within areas. What I've also then done, and Carmel's going to talk about this in a bit more detail later on, is I have configured the pop-up on this map. So rather than just displaying the attributes of these hotspots, what I've done is I've put in a custom expression and using Arcade. And what this allows me to do is put an expression in that says that if the feature that the user's clicked on has a count of HMOs greater than 10, display that the application is likely to be refused. Otherwise, tell them it's likely to be approved. So instantly, this gives them the ability, your landlords, the ability to go and click on the map and instantly see whether that application is likely to be approved or refused. And I think that gives a very intuitive and a powerful way of presenting to your landlords whether or not their application is likely to be approved or not. So how do you get that map into your application? Again, the platform and our APIs make this actually very simple. So like before, to do this, I'm going to add some additional modules from our JavaScript API. I'm adding the web map module and the map view module. So the web map allows us to instantiate a web map from your ArcGIS Online item. So simply by taking the ID from this URL here and instantiating an object and putting it into there, it instantiates that map within our application. And then I use the map view to put that web map into a div in my application. And what this ultimately gives us is this. So that what that would allow your user to do is to come in here and they'd be able to see that their address out here in Glasgow is not within the council boundary. Therefore, they'd know that work shouldn't be applying there. But equally, they can zoom in and say, well, actually, I'm interested in buying a property here. Is my application to turn it into HMO likely to be approved or not? Or I'm looking to do one here. Is it likely to be approved or not? In this case, it's not. Again, you see how in just a few lines of code, you're able to embed powerful and intuitive maps into your application. But wouldn't it be also... The next, sorry, got a bit lost here. So, in any case, in order for the licensing committee to approve or reject this application, they would need some statistics and some information to help them make that decision. Wouldn't it be useful if when someone inputted address into this application, such as 12 London Street, it worked out those statistics for the officer and notified the user of what those would be. So in this case, you can see that 210, there are 210 HMOs within 500 meters of the address I've just selected. There are 233 residential properties, so 90% of these properties are HMOs, and there are 818 bedrooms available. All useful information to help the licensing committee work out whether they should approve or reject it. You might be surprised by this answer that it's saying that it would approve it. I guess that's because, and you'll see in the code how I've set this up, there is also this sentiment that if something's already a ghetto, why not? Why not just fill it up anyway? And you'll see how I've done that in the code. But again, you can see how that would be useful, and again, would eliminate the need for someone manually sitting there with a map working out the number of HMOs and the likelihood to approve. But equally, you can see how powerful that would be to a landlord who could now decide whether he wants to spend his £50 or not applying for a HMO license, or £500. Again, I don't actually know. Does anyone here know how much a HMO license costs? Yeah, but ultimately it saves them spending their money. They would know instantly whether they're likely to be approved or not, obviously with some caveats. So let's look at the code and see how that is implemented. So again, what I've done is if we go down to the code that we looked at earlier around working out whether the property is within the council boundaries or not, that code is exactly the same, but you see I've added a function here called evaluate HMO. And what we're passing into this function is the geometry, the address that the user's selected. So if we look at what that function does, you can see that it instantiates a feature layer using the HMO layer that I showed you earlier with dots representing the location of every HMO. I then apply a 500 meter buffer to that so that I can use the 500 meter buffer to query the data. I instantiate a query. I decide which fields. In this case, I want all the fields. And then I do a query on that HMO layer using that query. And in this case, when I get the results, it's not a black or white, yes or no, I got results, therefore I'm in the council boundary. I want to interrogate those results. So what I'm doing is I'm counting the number of results returned to give me the count of HMOs. I'm then using that count and working out a percentage against the number of properties in that area. And then I am working out whether we're recommending or not based upon that percentage. And I'm saying if the percentage is greater than 10%, and less than 50%, then tell them it's unlikely to be approved. Otherwise, tell them it is likely to approve. In addition, what I'm doing here to get a bit more in-depth information is I'm then going through and finding the number of bedrooms in each of those, in each HMO. And I'm looping through and I'm counting up the number of bedrooms so that I can present that information to the user of the application. And then simply I'm just writing that information out to the screen. So again, you can see how in what is a relatively low number of lines, I've been able to add spatial intelligence to what was essentially a relatively dumb forms application. It might help if I... Okay, so what we've been able to do using the REST API, using ArcGIS Online as a map author, using the JavaScript API, is I've been able to remove the need for that manual analysis. In this case, it saved them basically one person full-time a year in terms of costs. So ultimately, the solution saves time and money. It also reduces the possibility for human error and subjectivity. It makes the answer pretty much objective. It provides a better service to the landlords and the citizens because it provides an instant response in terms of whether they're likely to be approved or not. So, I've got about 10 minutes left, and I was going to go and dig a bit deeper and go into some of the stuff that Richard was looking at earlier in terms of what's possible in terms of the JavaScript API and the REST API. But again, it depends what your feelings are, but I thought it might be useful to hear some of the things that have a bit of a Q&A and ask what sort of things you are looking to do within your applications and see if we can discuss these. Has anyone got any sort of questions or things that they'd like to ask about in terms of what's possible? I think this is going to backfire on me. Well, if not, I want to probably just, please, I mean, I'm around all day, Richard's around, and there's plenty of us from Esri here today, so if you do have questions or things that you just want to know, is this possible, please do come and speak to us. Oh, there's one at the top. Okay. Okay. So Ken's question is, he kind of pre-warned me about this one. He didn't say he was going to ask it here. His interest is that they have point data that they collect from the GPS and gritters, and they want to be able to intuitively or with a high level of I won't say accuracy or high, what's the term I'm looking for here? Essentially want to identify which routes have been gritted based upon those points. So the best option I would suggest to that would be to use the REST API or a network services in the REST API. Essentially what they would allow you to do is use those points to as waypoints on a route, because you would know that all of these points came from gritter A. You'd be able to use those as waypoints and do a network solve on it, which would try and join those points up through the most likely route that the truck would have taken to traverse from one point to the next. It won't give you 100% accuracy because they might have decided to have, again, it comes down to how frequently those points are pulled, those GPS coordinates are pulled, but it would give you the ability, and you'd be able to do that through both the JavaScript API has wrappers that would allow you to push in that data and spit out the new lines. But you'd also be able to do it directly with REST if you wanted to do it as a server-side process as well. Is that okay, Ken? Okay. Any other questions or thoughts or?
Presuming that you use a JavaScript API, that you could probably the Qt would do the similar thing.
Yep, so Qt will be able to interact with REST as well. Like I think both Charles and Richard have kind of made this point that pretty much everything we do in our client-side applications are really wrappers on REST and chain REST events together. And I think that's really, really important, because what that means is it gives you, as developers, the power to do pretty much everything we do in our COTS applications. There may be a few exceptions in Qt. I'm just trying to see if any of my colleagues are here who might be able to. Oh, is Mark up there? Yep. 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 Okay. Any further questions? I've got 3 minutes left. If not, I just want to kind of just talk about one last thing to consider. Who here's heard of webhooks? So there's a few of you have heard of webhooks. Webhooks are, I think the concept isn't relatively new, but they're something that is being built into a lot of applications now, where if you've ever done JavaScript development, you'll have heard this concept of publish and subscribe, where you publish events and you have lots of different bits of code listening for those events. Webhooks are something similar, but on the cross-application level. So applications like Dynamics and some of our stuff will publish events out, and you can then subscribe to those events. What this allows you to do is to have what it really allows you to do is to extend applications without extending that application. So let me just take an example for you. Imagine you have an application that allows a call center to report streetlight repairs. And you've built your nice forms application that allows your operative to go in there, type in, put the information in, and the next stage of that is to assign it to the right team based upon the area that they work in. You could use the examples that I've shown today and embed JavaScript into that application, embed REST requests to go and query a map to find out which area the streetlight lives in, and therefore choose the right team and populate the team in your system. But what that does is it ties you in so that if you need to make a change to your Java, every time you upgrade or do something on your main application, you'd need to look at that code and make sure it still worked. What webhooks would allow you to do is have your forms application over here and have it listening to, use something like Microsoft Flow to listen to the event, and when someone assigned that case to the status of ready for assigning to team, your webhook could listen to that, then go off and call our REST API, go and work out which team it is, and then pass back that information and write it back into your original application, loosely coupling that intelligence and allowing you to add spatial intelligence without necessarily changing your front-end application. That becomes even more powerful when you think about things in terms of streetlight failures. One of the things that costs them the most money is repeat visits. So, for example, they may know that streetlight A is not working, and they'll go out with their van and realize that they don't have the right equipment to get up to that streetlight to repair it. So imagine if you could have an event that said it's been assigned, go and get which team is required to go and repair that streetlight, but equally go and see what the service type using master map data underneath that streetlight is, or see how far that streetlight is from the roadside to see whether I need a cherry picker, a ladder, or some other specialized equipment in order to do that. And by doing that spatial query, you can then ensure that whoever's assigned that job goes out to that job with the right equipment to repair that streetlight. So the benefit of webhooks is it means that you can add spatial intelligence without modifying essentially your core application. And webhooks are being built more and more into our application. At the moment, at 10.7.1 in ArcGIS Enterprise, you can hook into events around items and changes to the administrative side of ArcGIS Enterprise But in the future, you'll be able to hook into when data changes. So if someone comes in and changes data through the GIS, you'll be able to trigger events using webhooks based upon those changes, which in itself is extremely powerful. I hope you found today useful. I think I hope you can see how using our APIs and the ArcGIS platform, you can, in a relatively simply, add spatial intelligence into your existing applications. Thank you.